VSEPR theory. VSEPR theory, that means V से valence, S से cell, E से electron, P से pair, R से repulsion theory. Okay, valence, cell, electron, pair, repulsion theory. VSEPR theory. Okay. This theory was proposed by Sidgwick and Pauli. Sidgwick and Pauli. Which? Sidgwick and Pauli. Powell. Okay. This theory was proposed by Sidgwick and Powell in 1940. Okay. This theory was proposed by Sidgwick and Pauli in 1940 to predict the geometry of molecules. Okay. Gillespie and Noyon advanced the Sidgwick-Pauli theory in 1957. Okay. Gillespie and Noyon. Gillespie and Noyon advanced the Sidgwick-Pauli theory in 1915. Okay, and also proposed the name valence cell electron pair repulsion, and also proposed the name valence cell electron pair repulsion theory. Okay, so this theory is called Gillespie-Noyon theory according to this theory. Okay, Gillespie-Noyon theory. Okay. So this theory is also called Gillespie-Noyon theory according to this theory. Okay. This theory was proposed by Sidgwick. And Powell in 1940 to predict the geometry of molecules. Okay. Gillespie and Noyon advanced the Sidgwick-Pauli theory in 19. Gillespie and Noyon advanced the theory of Sidgwick and Powell theory in 1957. And also proposed the name valence cell electron pair theory. Valence cell electron pair repulsion theory, or Gillespie-Noyon theory. Okay, so this theory is also called the Gillespie-Noyon theory according to this theory. According to this theory for the maximum stability of a molecule, for the maximum stability of a molecule, it is essential that the orbitals containing valence electron pair valence electron pair containing valence electron pair of central atoms of molecules. Pairs of central atoms of molecule, okay, must be directed in space, that they lie far away from one another, our repulsion is minimum. Our repulsion is minimum, okay? Minimum. For the maximum stability of a molecule, it is essential that the orbitals containing valence electron pair of central atoms of molecule must be directed in space, that they lie far away from another. Our repulsion is minimum. Okay. The molecules thus have minimum energy and maximum stability. Okay. The molecules thus have minimum energy and maximum stability. Okay. According to VSEPR theory, for the maximum stability of a molecule, it is essential that the orbitals containing valence electron pair of central atoms of molecule must be directed in space, that they lie far away from another. Our repulsion is minimum. Okay. The molecules thus have minimum energy and maximum stability. The geometry of molecules depend on the arrangement of the orbitals around the central atom or bond angles. There are several rules which determine the geometry of the molecule. The main postulates of VSEPR theory are as follows. Main postulates of VSEPR theory. First point. If the central atom is surrounded by orbitals, if the central atom is surrounded by orbitals containing shared pair of electrons, is that bond pairs, then the shape then the shape of the molecules is irregular. Shape of the molecules shape of the molecules is regular. Okay? Regular. Second point. First point, if the central atom is surrounded by orbitals containing shared pair of electrons, is that then the shape of the molecules is regular. Second point, when bond pair and the lone pair, when bond pair and lone pair both are present around the central atom, the molecules will have irregular shape. Okay? Irregular shape. Okay? When a bond pair and a lone pair both are represent around the central atom, the molecule will have irregular shape. Okay? And first, if the central atom is surrounded by orbitals containing shared pair of electron bond pair, then the shape of the molecules is regular. And when the bond pair and lone pair both are present around the central atom, the molecules will have irregular shape. Okay? Third point, lone pairs electrons repel adjacent electron pairs more strongly. Electrons pairs more strongly than the bonding electrons pairs. BP bonding electrons pairs. The repulsion has the order as the repulsion has the order as lone pair is greater than lone pair, bond pair is greater than bond pair. Okay? Strongest, this is lone pair strongest, and this bond pair weakest. Okay? Lone pair electrons repel adjacent electrons pairs more strongly than the bond electrons pairs. Okay? The repulsion has the order as lone pair repulsion is strongest and bond pair is weakest. Okay? And bond angles in methane, ammonia, water explained by this rule. Okay? Okay? The methane and bond angles in methane, CH4, ammonia, NH3, and water H2O. Water H2O. Okay. Ammonia bond angle is 109 degree 28 minute, and methane bond angle 109 degree 28 minute, and ammonia bond angle 107.3 degree, and water bond angle 104.5 degree. Okay. Then carbon, 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen. This is the structure of methane. This is the structure of methane. And the ammonia, structure of ammonia: 1 hydrogen, 2 hydrogen, 3 hydrogen, and 1 is lone pair. Okay. And the structure of water. Structure of water. This is oxygen, 1 hydrogen, 2 hydrogen, and okay. This is the structure of water. Okay. There is no lone pair on carbon. There is no lone pair on carbon in methane. There is no lone pair on carbon in methane. There is one lone pair on nitrogen. There is one lone pair on nitrogen in ammonia. And there are two lone pairs. 1, 2. There are two lone pairs present on central atom oxygen. On central atom oxygen in water molecules. Okay. In methane CH4 methane molecules, the carbon atom is surrounded by 4 bonded electrons. 4 bonded electrons pairs. The molecule is a tetrahedral and the bond angle is 109 degree 28 minute. The ammonia molecules contains 3 bond pairs. 1, 2, 3. 1, 2, 3. 3 bond pairs. Contains 3 bond pairs and 1 lone pairs. Okay. Of electrons. 1 lone pairs of electrons. Okay. Due to lone pair bond pair, repulsion angle in ammonia is lower than 109 degree 28 minute and is 107.3 degree. The water molecules contains 2 bond pairs of electrons. Okay. In case of H2O, there are lone pair. In case of H2O, there are lone pairs as well as lone pairs, bond pairs, repulsion, and hence angle is 104.5 degree. Okay. Hence lone pair, as well as lone pair, bond pair, repulsion decreases angle. Thus presence of lone pairs of electrons affect geometry of the molecules, and so the bond angle gets reduced. Okay. Then the bond angles of water is 104.5 degree. 104.5 degree. Okay. 1 minute. Next point. Okay. 1 minute. Next point. Next point. Point 4. Point number 4. Repulsion is started by repulsion, okay? 1 minute. Point 4. Point 4. Okay. Repulsion is exerted by the bond pair. Repulsion exerted by the bond pair. Repulsion exerted by the bond pairs decreases as repulsion exerted by the bond pair decreases as the electronegativity of the bonded atoms increase, hence the bond angle will decrease. Hence the bond angle will decrease. Okay. Repulsion exerted by the bond pairs decreases as the electronegativity of the bonded atoms increases, hence the bond angle will decreases. Bond angles will decreases. Okay. Then point A. Okay. Point A. Okay. H2O. 104.5 degree and F2O 103.2 degree and A point. Due to lone pair and lone pair bond pair, repulsion angle is lowered below 109 degree 28 minutes in H2O and F2O. F is more electronegativity. Than H, hence charge density on oxygen. In F2O is less and on oxygen in H2O is more. Okay. Due to bond pair repulsion angle opens more in H2O and less in F2O. Thus, as the electronegativity of terminal atoms increases, the bond angle decreases. Okay. Similarly, in case B, bond angles can be explained through bond angles NH3 107.3 degree is greater than NF3 102 degree. Okay. 102 degree. Okay. And this point is V point. Okay. And point number 5. Repulsion between electrons pair in filled cell are greater than electrons pair in incomplete cell. Okay. Repulsion between between electron pairs in field cells are greater than electron pairs in incomplete cells. Okay, incomplete cells. Example: A. H2O 104.5 degree, H2S 92.2 degree, H2SE 91.0 degree, and H2TE 89.5 degree. Okay, 89.5 degree. B. NH3 107.3 degree, pH3 93.3 degree, and ASH3 91.8 degree, and SBH3 91.3 degree. Okay. Repulsion between lone pair in field cell of oxygen is greater than in incomplete field of S, Sc and Te. Okay. Similarly, repulsion between lone pairs in field cell of nitrogen is greater than incomplete field phosphorus, arsenic and Hb. Okay. Bismuth. Hence bond angles decreases. Okay. 6.6. Multiple bonds do not affect the stereochemistry of molecule. Okay. Multiple bond do not affect multiple bonds do not affect the stereochemistry of molecule. Okay. Pi bonds do not affect the geometry of a molecule. Okay. Multiple bond do not affect the stereochemistry of a molecule. Pi bonds do not affect the geometry of a molecule. Okay. 7 point. Point number 7. 7 point. Okay. The geometry of the molecule is determined. The geometry of molecule is determined by the number of sigma bonds and lone pairs. Okay. The geometry of molecule is determined by the number of sigma bond and lone pairs. Okay. Next, limitation of VSEPR theory. Okay. Limitation of particles in elastic position.